Yeah, Robin, welcome on our DataOps stage. So it's your time. Enjoy.
Okay, thank you very much. Thank you for having me here. So today I'm going to talk about Apache Kafka and something called ksqlDB and about building streaming data pipelines. I work at a company called Confluent as a developer advocate. That's Confluent, not Confluence. We work with Apache Kafka, nothing to do with wikis. My background is in data engineering, data warehouses, that kind of stuff. Recently, I've been dabbling in trying to learn how to code. I've been looking at Go, which has been kind of exciting. You can read about that if you want to on my blog. I've also got a YouTube channel, courtesy of Lockdown. So you can go and find a bunch more resources there. I do lots of tweeting. If you like Twitters, then you can find me. I'm at Armoth on Twitter. So send me a message there. It's always good to get feedback from talks. If you've enjoyed it, if you've not enjoyed it, then let me know. I'm going to talk about building streaming data pipelines, and we're going to get into some code and some live demos and all sorts of fun stuff like that. But I thought it'd be useful to start off by just kind of setting an expectation and understanding of what Apache Kafka is, because lots of people have heard of it. Many people haven't, but lots have. But not everyone has the same understanding of actually what it is. So Kafka is an event streaming platform. It's distributed, it's highly performant, and it lets you do a lot more than just like PubSub, than just like a message bus that some people think of it as. So it lets you build systems that are highly performant, that are distributed, that are nicely loosely coupled. It lets you interchange data between all sorts of different applications and databases and services that you're building. At the very heart of Kafka is this thing called the log. And around it, you've got a set of different APIs that let you use it and integrate it with other different systems in the best kind of way. But at the very heart of it is the log. And what the log is it's actually a very, very simple concept. It says when something happens, when an event happens, we'll append it to the log. So an event could be a temperature reading from a thermometer sensor, an IoT device. It could be a customer walked into your shop. It could be a customer phoned your call center. It could be some inventory moved around in the warehouse. An event is something happened in the world. And that could be machine generated or human generated. And events hold date. So what was it that the customer bought? And also notification, something has been bought. So events are very powerful, and they let us build these great systems, but at the heart of it is this idea of an immutable event log. It's immutable. You can't go back and change it. If you put something there that is incorrect, you put something else there subsequently to counteract that initial mistake, but you can't go back and change it. So at the heart is this log, and to actually make it something that we can work with, we split it up into what are called topics. So topics are kind of like, if you're from a database background like myself, they're kind of like tables. It's how you carve up your different entities and you arrange your data so you can read and write from the correct place. So we might have a topic which holds information about clicks on our website, or information about our customers, or about the orders that are being placed. And then within the topics themselves, we carve them up one more time into what are called partitions. Partitions are there because they give us our scalability, because partitions can be distributed across multiple separate Kafka brokers, which means you can scale out your storage and you can scale out your processing. I just said storage because Kafka includes a storage component. It's not just like a transient message queue. It definitely is not that. What Kafka lets you do is take events and write them onto a log and make them available to consume to read, but that data doesn't get deleted from Kafka until you tell it to do so. You can say, on this particular topic, on the clicks topic, I would like to keep data for 7 days, or 7 years, or in fact, forever. Data, probably keeping it forever doesn't make a whole bunch of sense, but there are some things like order information that is always going to be useful. So you could say, actually, on this particular topic, we'll keep it forever, and that's totally valid. Within the partitions themselves, the actual events that we're putting onto this log, messages have bits of metadata around them, like timestamps and things like that. But at the heart of it is a key and a value. And that value could be a huge, complex schema, and So could the key, actually, if you want it to be, but they're just bytes. So your application serializes the data in the way which you choose. It's just bytes that you write onto Kafka. So Kafka is extremely agnostic when it comes to the actual data formats. You've got a protocol and you produce the data, you consume the data, but it's up to you as the user of Kafka, whether it's a producer or a consumer or both, to decide, well, how am I going to serialize my data? And at this point, we've got to talk about schemas, because how you serialize your data has implications for how you're going to manage your schemas as well. And today we're talking about building streaming data pipelines. And if one part of the pipeline changes the schema and other pieces don't know about it, or if one part of my pipeline is producing data and another part wants to use that data, the schema is critical for making that happen as smoothly as possible, and also for kind of like stopping us making errors or making changes to the schema when someone else doesn't know about it and it's going to break things for them. So use something like Avro, use Protobuf, use JSON schema. Those are great ways to serialize your data. You've got a schema registry that stores the schema. You use JSON if you want to, but JSON doesn't have built-in support for schemas, and CSV is like a generally terrible idea, so don't do that. When it comes to reading data from Kafka, consumers can do so completely independently, and you can have multiple consumers. You don't have to declare your consumers up front. Your producer produces the data to the topic. That's all that the producer needs to do. So when you deploy Kafka, you set up your brokers, you have your producer writing data, and you're good to go. And then consumers can come along initially or subsequently and say, oh, I'm interested in reading data from that topic. As long as that data hasn't aged out, I talked about earlier, it gets stored until it gets deleted. As long as that data hasn't aged out, then consumers can all access that data independently of each other. So when a consumer comes along, it says to Kafka, like, I'm a consumer called Sally, and I'd like to read the data from the topic. And Sally can say, I would like to go back to the beginning of the topic and read all of the data. Or she can say, I would like to just read any new messages that arrive. But assuming that she goes back to the beginning of the topic and reads all of the data, and then disconnects because she's done her work or whatever, when she reconnects, Kafka will know where she got to last time. It's called the offset. And we'll say, okay, here are the new messages since you last read from this topic. And then Fred comes along and Fred can read messages from the topic, as can George. But the point here is just because one consumer has read those messages, nothing happens to them. They don't get deleted just because one has read them. There's no correlation between reading messages and deleting messages. The processes happen completely separately. And this means that you can have consumers coming along, reading data. You might have a consumer that reads the data, and then that consumer falls over and crashes or something. The messages aren't going to kind of like bubble up and kind of like get bigger and bigger and bigger until that consumer reconnects and causes the kind of problems we see in other systems. The messages will stay on that log as long as you've told Kafka to keep them, and then they get deleted off. And you can increase the retention if you realize that actually that consumer over there, we actually really do need to read those messages, but they're separate concepts, the consumption and the deletion of messages. That's a rather rapid overview of what Kafka is. It hopefully gives us a base understanding of what we're talking about in terms of messages coming on and being available to different consumers. There's a ton of really good books that you can get available for free off our website. You go along to the link or scan the QR code, and from here you can find out a whole bunch more about Kafka, about the internals, about the concepts. Like iHargs is a great way to get started. The concept of a distributed commit log and why is it such a powerful construct on which to build our systems. I'll put the link up again at the end of the slides. I'll also share it on the meetup group and anywhere else I can find to share it. But now let's talk about what we came along today for, which is building streaming data pipelines. Streaming data pipelines kind of like sounds fancy, but it's an evolution of what we've done for many, many decades really in computing, which is taking data from one place and putting it somewhere else. And that could be for fairly simple reasons, which is I've got somewhere I'm storing data over here and it'd be cheaper to store it over there. So I'm going to take data from my transactional database, I'm going to go and put it into S3. And we can use Kafka to facilitate that. We can say, right, okay, we're going to ingest the data from the database as it changes. And as we receive those changes in Kafka, we'll push them to S3. So we build ourselves a nice little pipeline here. But because we're using Kafka, we could add in other databases, and the S3 consumption remains the same. We could add in additional consumers. We could say, well, we started off with S3. We also want that data on premises, so we'll add in HDFS as a target here. So we have the data coming in one place and being available in multiple ones. Kafka provides us the back pressure. It also gives us the loose coupling, which means that if one component goes offline, the others don't grind to a halt. They just sit there and wait for their data to come along. But data pipelines can get more complex. We can say, well, instead of just shunting the data around as is, we can say, well, we've got some data in the database. We've got some data from somewhere else. Maybe we've got a microservice that's writing data down to Kafka. Maybe we've got a different database writing data into Kafka. Maybe we've got a message queue writing data into Kafka. The point is we have data arriving in Kafka from numerous different places. And perhaps we want to process that data before we push it on somewhere else. So we say we've got order information coming from a microservice. We want to look up information about those orders, the customers. We want to do that join. And we can do that within Kafka. We're using stream processing. And we can take that data and we can push it already denormalized and transformed to a target system downstream. And because we're doing this event by event, we're doing it in near real time, it means that we don't have to be dealing with batches of data and taking a batch from here and a batch of there and writing it there and then processing it there. And then the user can access that data that's been enriched and transformed. We say, as these events happen, we'll enrich them and transform them and then push them down to a target system all ready for consumption. And there are two components that we need to consider when it comes to building out a streaming data pipeline. We've got the integration piece. How do we get data from here into there and from here into there? And we've got the stream processing piece. Stream processing could be we're doing transformations and we're filtering and we're joining and we're aggregating and doing all that kind of stuff. Stream processing could also be something like, well, when this data comes in, I just want to drop these particular fields, or I want to filter it for this particular condition. So it doesn't have to be big and advanced and fancy when it comes to stream processing. It can just be, as the data flows through, we just tweak the schema, we just change this little thing, and then it carries on its journey through. For integration, there is one way that you probably should be doing it if you're using Apache Kafka. There are many different ways, but there's one which should be your go-to assumption. This is what we'll probably use, and we might evaluate it and do something else, but probably we're going to use this one, and that's Kafka Connect. And that's because Kafka Connect is part of Apache Kafka. So it's tightly entwined within Apache Kafka. If you're using Apache Kafka, you already have Kafka Connect. What Kafka Connect lets you is integrate with systems upstream into Kafka, from Kafka downstream to numerous other different systems. So you can do integration from all these different technologies and do so just using JSON configuration files. So sometimes people have the temptation to say, well, I'll write myself a little bit of code. I'll write a bit of Java, I'll write a bit of PL SQL, I'll write a bit of code to do this integration piece because that's what I'm familiar with, or I'm not aware of Kafka Connect, or for whatever reason. Avoid that temptation, because Kafka Connect gives you this functionality and it lets you declare what you want to do so using just configuration. So you specify your configuration, you specify how you want to do your serialization and deserialization, and it's a pluggable architecture. So you say, I've got my connector with a specific technology piece. So I want to bring in data from ActiveMQ. Here is my ActiveMQ connector. Then you say, I've got my transformations. As this data comes in, I would like to drop these fields and rename these ones. And then you've got your converter. So your converter says, I'm going to serialize this data into protobuf. But because it's a pluggable architecture, you can mix and match these different things. You don't have to say, oh, well, there's an ActiveMQ connector, but it doesn't allow me to use protobuf. Because if it's written properly, it won't know anything about protobuf. Not just like internally within this little green box here, it'll pass a representation of the data. And all you do as a user is say, here is my configuration, and you'll have a line on there which says, and I want to use protobuf, or I want to use Avro, or I want to use JSON. But it's just a line of configuration, and you can just mix and match these different pieces together. You can use Confluent Hub to go and find all these different connectors and transformations and converters. So you see, I've got data, it's sat in Kafka, and we want to get it into Elasticsearch. So we type in Elasticsearch, says, to running Kafka Connect, you can do so using what's called a standalone worker. And this is just an isolated JVM. It uses flat files locally to store your configuration and things like offsets, which is where it's got to in its processing. It's not very scalable, or it isn't scalable. You can only scale that single worker machine upwards and put in more CPU cores and more network cards. You can't scale it out. And it's not fault tolerant because you've got a single one of them. If it goes bang, well, you don't have any processing. So a much better option is using Kafka Connect with distributed workers. And I'll let you in a little secret here. It's called distributed, but you can totally run it on a single node. So if you want to have a single distributed worker on a single node, that's totally fine. And in fact, that's a really good idea if you're just starting out. You're just playing around with it. It's like, well, there's this Kafka Connect thing. Start off with a distributed worker. There are a few use cases where you'd have a standalone worker, but most of the time you have distributed. It just happens to be on one machine. As you want to scale out, as you want fault tolerance, you just add in more workers into that cluster, but the configuration and so on remains exactly the same. You can have a single cluster of distributed workers. You can have multiple clusters of distributed workers. But it's up to you how you deploy it, but it gives you this ability to have scalability, so you can increase your throughput as you need to, and also resilience. So if you lose a worker, other workers will take over that workload for you. So integration, we're going to do probably using Kafka Connect. That configuration, pull in data from here and put it into Kafka, take data from this Kafka topic and put it over there. For stream processing, the other piece of the pipeline puzzle, we're going to use something called ksqlDB or Kafka Streams. So Kafka Streams, it's a Java API, it's part of Apache Kafka, and ksqlDB is part of Confluent platform, it's community licensed, and it's written on top of Kafka Streams. It's a further abstraction on top of it. And if we think about the kind of data, the kind of events that we sometimes end up working with, here's an example that I've made up. It comes from a factory, and you've got various things they made in the factory. And from all of our different robots, we've instrumented the production line, and we get back this information about what's going on. We've got all these sensors, and so we've got the sensor ID and the time at which the reading was taken. And then we've got some information about those readings, or about the widgets that were passing along. What kind of widget was it? What was the temperature when we took the reading? What was the weight of it? And with this data, there are fairly common patterns that we want to apply to it. So whatever your domain in which you're working, there's only so many different ways that we manipulate data. We maybe say we want to do an alert. We want to look for an exception in the data, and so we want to raise an alert based on that exception. Or we want to start to analyze the data and start to group it up and look at an aggregate across it. Or we may want to do both. We want to take an aggregate and join it to something else and kind of do more complex work on top of that. We want to do something on these events as they come in, maybe stateful, maybe stateless. Sometimes we want to take that data and we want to put it somewhere else. We want to put it into our data lake so we can do some machine learning on it. We want to go and put it into S3 or Snowflake to run our reporting against it. So some of this data we want to process as we encounter it, as the events arrive. Some of the data we maybe want to enrich and then go and put somewhere else. And ksqlDB lets us do this with our data. So you can say, well, for the alerting, we're going to run a SQL statement which says, select everything from a stream with a predicate. Where it matches this condition, we're going to pick up those particular events. And when you run ksqlDB, it's a continuous query. So this select doesn't run against like a lump of state in a database table. It's running against a stream of events. And we can say start at the beginning of that stream, start at the beginning of that topic and process those events as you encounter. And you can also say, well, as new events arrive, apply that same logic to it. Select these particular fields where this condition is true. We can do aggregations using ksqlDB. So we can do stateful aggregations and say, well, how many widgets are being created, broken down by different production line? Or we can do more complex work. We can start to use some functions and say, well, take an average of this, broken down by this within a particular time window. We can use having to apply predicates to it as well. But with ksqlDB, we can also say, well, take this data and go and put it somewhere else. Create a sync connector to go and put the data over there, or create a source connector to pull in data from here into ksqlDB. So ksqlDB is built on top of Kafka Streams. So everything I'm showing you here, you could write using Kafka Streams. If you prefer using Java, that's great. If you'd rather use SQL, then ksqlDB gives you that level of abstraction. At the heart of it, ksqlDB is just a producer and consumer on Kafka topics. So we take a source stream that comes in through a Kafka topic, and we do something to it. So we say, well, we're going to filter it for this particular condition. The output of a ksqlDB statement is generally going to be another Kafka topic. So we take this particular stream and we filter it for a condition. Or we take this particular stream and we join it to another one, but the result goes back onto a Kafka topic. We could take that Kafka topic and we can process it further. So you can easily chain your transformations. But we might say, well, we've done the work that we need to, and now we take that and we say all orders where status equals shipped. That writes back onto a new Kafka topic. Every event that comes in goes through that logic and gets written to a Kafka topic if it meets those criteria. And now our service simply subscribes to that Kafka topic, and it has a feed of completed orders. We can also use ksqlDB to support our applications and microservices that we're writing, not necessarily from a subscription point of view, actually from a lookup point of view. And this is where the DB bit of the name comes in. So we've got ksqlDB. It's called DB because within ksqlDB, it actually materializes state. So if we're doing a stateless transformation, like select from here where this condition is met, it's just like taking an event, it looks at the event, is it matched, it writes it over here. If we do a stateful aggregation, like we do a count across them, so select how many widgets there were within a time window. Within ksqlDB, will say, well, I'm running this continuous query, this stateful aggregation. I basically have a materialized view, and here is the result. It says for this particular account, the balance is this. So ksqlDB, just like Kafka Connect, you can run as a single instance, but you can also scale it. So we have our Kafka cluster, and our Kafka brokers, by the way, all that runs on a Kafka broker is your Kafka broker. You don't want to run anything else on that particular machine or pod or however you're deploying it. You might have Zookeeper, but that's going away soon anyway. But you definitely don't have Kafka Connect running on it. You definitely don't have ksqlDB running on it. You don't have anything else running on it. So ksqlDB, we deploy separately. It's also just a JVM process. And we can have one, and we can have many. And as we scale it out, the work will get allocated and processed, split out by the partitions that we have in our source data. We can cluster ksqlDB into a particular cluster, but these clusters we want to deploy based on a concept of applications. So it's not like, here is my warehouse ksqlDB cluster, and everything is going to run within that one big cluster. Instead, we think of actually applications. So we're going to have a ksqlDB cluster that supports this function, a ksqlDB cluster that supports this application, a ksqlDB cluster that maybe is just like a sandbox environment. But you're definitely going to be carving it up and deploying it in terms of applications. So let's now actually see what this is like in action. It's enough kind of like showing you the slides and waving my hand, but it always makes sense or more sense when you actually see what it looks like in action. The example I want to show you is based around the idea of a website. And on this website, you can leave reviews. It's like every website out there nowadays sends you an email afterwards and like, would you like to leave a rating, whatever. And so on this website here, you can leave reviews, and the website code, it uses the producer API for Kafka to write those ratings into a Kafka topic. So you can see at the bottom right of the screen there, this is the kind of payload that we're getting back. We're finding out the ID of the rating. We find out the rating itself on a scale of 1 to 5, the star rating. So 4 out of 5 is kind of pretty good. The message, the device it was left with, and that kind of stuff. So we're going to take that and we're going to enrich it with information about the user who left that rating. So instead of saying like, here we've got like user ID 3, we're going to say, well, user ID 3, it turns out their name is this, and their email address is this, and their club status is this. So that's going to be useful because we're going to take that and we can now build ourselves an operational dashboard using like Elasticsearch. Well, here are our ratings and here are our customers, which have disappeared from our diagram. We can join those together, write that denormalized information completely broken. We're for that and write it to a new Kafka topic. And on that Kafka topic, our application simply subscribes to that topic. If I get a message on that topic, I now need to go and phone that customer or page the ops team or do something to actually see if we can do something to make things better for that customer. But you can encapsulate that logic of if it's a negative review and they're an important customer, write it out to a new topic, which then triggers that notification application to go and do something based on that event having happened. So let's see what that actually looks like in practice. I'm going to take a brief pause and have a look at the questions, see if any have come in. So, YouTube channel, does Kafka Connect for Elastic, is everything needed to stream data into Elasticsearch, or is there a Firebase or similar demanded? So Kafka Connect for Elasticsearch, which I'm actually going to show you as part of this demo, it is all you need for getting data from Kafka into Elasticsearch. So Firebase is one way of doing it, Logstash is another way of doing it, Kafka Connect is probably your default option if you're talking about Kafka. If you're talking about like flat files or something else, then those other options are great. If you've got data in Kafka, you already have Kafka Connect. And so something like Kafka Connect with the Elasticsearch connector is a great way to get data into Elasticsearch. So let me show you that. So what I'm showing you here, in fact, let me put it on the screen so that I can demonstrate it. We've got a repository, so a Confluent GitHub. So if you go to Confluent Inc. and then demo scene, this is where all the demos are that we run. It's not polished, it's not QA'd, like every new release we don't like bump the versions and test it and do all that kind of stuff, but we do test it for like the here and now. So like the demo I'm going to show you today, I've tested it, I've checked it into the master branch, and it works, hopefully. I'll explain why it might not in a moment. But you can go along here and you can try all the different demos that we're working on, all the different kind of concepts and stuff. So if you want to know about Elasticsearch, there's actually a demo entirely dedicated to that down here, Kafka to Elasticsearch, Kafka to S3. So all sorts of stuff to kind of poke around with. And what it's got, so here's build a streaming pipeline, which is what we're doing today. It's got a Docker Compose, and it's got a script. So you'll actually see me looking at my screen down here. I've got the script for copying and pasting the different commands. But it means you can actually take this away afterwards and say Docker Compose up, and you'll spin up the full platform. You've got the script, and you can actually work it through and try this thing out just to kind of get even more of a feel for what it's actually all about. So that's the demo scene repository. Again, I'll share the link for that afterwards. So here we go. This is ksqlDB. There is a command line client, which is what I'm using here because I like using the command line. There's a web-based interface called Confluent Control Center. There's also a REST API and a Java client. So there's tons of different ways to work with it. But if you're just poking around, if you're just starting to get used to it, then the command line interface is like a great way to do so, as is the web-based interface. So we're going to start off by saying, what topics have I got on my cluster? I've got a topic called ratings. We can probably guess that on this topic is ratings data. If you're familiar with Kafka, you will know that you have things like the Kafka console consumer. You may even know about Kafka Cat, and if you don't, go and check it out because it's awesome. But with these things, you have to know how your data is serialized. You have to say, oh, well, it's an Avro, so I'll use the Avro Kafka console consumer, or I'll tell Kafka Cat to deserialize it using Avro. What ksqlDB lets you say is, well, I've got a topic, I wonder what's in it. print ratings. And I say, okay, I'll have a look at the data, and then I'll take a guess at how it's been serialized. So I say, okay, the key, it looks like JSON maybe, or it's just a string. The values format's Avro. Pretty sure of that, so I will go and deserialize it for you using the schema from the schema registry, which means we can then see it. We can see we've got a key for the data, and we've got a value. And this is the information, the payload that I showed you on that slide. So you've got a rating ID, you've got a user ID, a star rating, and so on. But we're going to do something with this. So to start off with, we're going to say, well, that's interesting. We've got our application writing data to Kafka, but we want to report on this in real time. So we're actually going to take this data, and we're going to say, well, let's go and put it into Elasticsearch. So here, I'm going to say, go and create a sync connector. So ksqlDB wraps around Kafka Connect as well. So you can use Kafka Connect standalone, and just like you use the REST APIs, configure it. You can also use ksqlDB. So just like you could also go and use a separate consumer to look at data in the topic, I fired up ksqlDB, I've looked at the topics on my cluster, I've previewed the contents of it. I can also go and create a connector. So you can actually do a lot of this from within just a single command line. So I'm going to create a sync connector. I'm going to say, here is the connector I would like to use, the Elasticsearch sync connector. Take data from this topic and go put it into Elasticsearch over here. And if I say show connectors, this is okay, it's running, which is good news. And it means we can go over to Kibana. If I show you this, zoom in a little bit. And over in Kibana, we can say, well, we've put some data into our Elasticsearch index. So here's our index called ratings. And we paste it in there, and it says it's got a time component, and it has called rating timestamp. And we create that. And we're also going to say use that as our default, which means we can head over to Discovery, and it says, well, here's your data. And if we tell it to refresh every second, we've now got data that's arriving in Kafka and being pushed from Kafka into Elasticsearch. And I've done that using one command, create sync connector. I could do it with the REST API as well and just post some JSON, but it's the same concept. Kafka Connect is connecting to Kafka topic and consuming it, pushing it down to Elasticsearch. I could scale it out. I could say drop particular fields. I could do all sorts of funky stuff like that within it, but it's just a command to run to take data from Kafka and go and push it somewhere else. So that's kind of useful. But all we've got in here is our raw information. We've got the rating ID, we've got the user ID. So who's user ID 12? Are they important? Are they a platinum customer? Who knows? Let's go and find out who they actually are. I'm going to do that by pulling in data from a database. So before we do that, actually I've skipped ahead a step, is we're going to take our data from that the stream that we've created. I'm going to say, right, take that topic called ratings and create a stream on top of it. So stream in ksqlDB is a Kafka topic with a schema. Where's our schema, you may well ask? Well, our schema, because we're using Avro, is in the schema registry. So ksqlDB says, well, I'll go to the schema registry and I will pull down that schema and I'll create you a stream, and we can say describe ratings, and let's say, here is your schema. So we have a schema whose user ID is an integer and the rating type is a big integer, and so on. So we've got data in a topic that has a schema, and most data has a schema. It's just some of the time we kind of like prefer to brush it under the carpet and pretend that it doesn't. Most data has a schema. When we're building systems that are communicating with others in a nicely loosely coupled way, the schema becomes your API. The schema is super important. So using something like Avro is a great idea. As users, as consumers of that data, our life is so much easier because we say, create a stream against this topic, and the data, by the way, is in Avro. What's the schema? It'll go and find out. If it's just in JSON, we have to go and phone up the team who wrote the data to the topic and say, well, what fields are there and what are the data types and what are they called and are there any defaults and all that kind of other stuff. And if it was ourselves who wrote that data to the topic, we have to make sure we keep things in sync, and then we go on holiday and someone else wants to use the data. And it's just a generally brittle way of doing things. So using Avro, using protobuf, using JSON schema is a much better way to do it. Because we've got a schema, we can now project certain fields. We can say, just pick out these particular fields from the data as it arrives. So it says, okay, here's the user ID, here's the stars, here's the channel, here's the message. You might notice as this data is going by, the channel has got different values. We've got iOS, we've got Android. We've also got one here called iOS test. So on our live stream of data, we've also got data in there that's not from a live system. We've got like test data that's coming into it, and it shouldn't really be there. So this is a good example of where we can use stream processing, not for like big, fancy, complex stuff, but just stream processing to actually modify the data and cleanse the data as it passes through the pipeline. Because we can do this. Take the data from that particular stream and apply a function to it, or a predicate, where the channel forced to lowercase is not matching this particular wildcard pattern. Select all of the messages from here where we don't have test as part of the channel name. So now we just have the production data, the data that's not coming from a channel with test in its name. And we can echo it out to the screen, which is moderately interesting, but we can also say, let's now actually put this back into Kafka. So we're going to create a new Kafka topic called ratings live as the results of this select statement. And this select statement is continuous. And we can also say, well, we'd like to pick up the test data as well, but we're going to go and write it somewhere else. We're going to write it to a test topic called ratings test. So we say where the channel is matching this particular pattern. Show streams. We've got two different streams now, ratings live and ratings test. So these are derived from the original ratings topic. And you can see here the Kafka topics, ratings live, ratings test. And I can actually say, take that particular topic and say, print that topic. This is, okay, here is a particular topic. And within that particular topic, we can see we've just got Android and web and Android and iOS and no test messages. So this could actually be the extent of our pipeline. A producer somewhere writes data into a Kafka topic. We've realized that there's like data coming in from other systems that shouldn't be there. We write a single or two SQL statements, one to create the stream, one to create the derived stream, to filter that out onto a new Kafka topic. And now whichever systems that need that data that doesn't have the test data in it can subscribe to that particular topic. You don't have to do kind of like big end-to-end fancy things. But let's go and do big end-to-end fancy things because it's much more fun. So now we are actually going to do what I promised earlier, which is take these user IDs and actually look them up and find out who is that particular user. And where do we look that up from? Well, where we keep our user information. Where do we keep our user information? And a lot of the time it sits in a database. So for the purposes of this, I'm using MySQL. What I'm going to show you applies to any relational database. It could be MySQL, it could be Oracle, Postgres, whichever relational database you're using, the concepts are the same. So we've got a table called customers. I'm going to take data from that table and say, just show me the first 5 rows. And we've got user ID, we've got first name, last name, email address, and we've got club status. So we know that user ID 1 is Rika Blaisdell. She's got an email address and a club status. So we can use this to enrich the information that we receive within that Kafka topic. So instead of saying, well, we're going to do lookups out to a database, which can be laggy or can like if you try and cache it locally, it gets out of date and so on. Instead, we're going to say, we're going to bring that database into Kafka, or that database table into Kafka. I'm going to do so extremely low latency. So it means any changes in the database will get reflected within that Kafka topic straight away. So we're going to use Kafka Connect again to do this. The connector this time is a bit more long-winded in its definition. So if I show you that, it looks like this. So the data is coming from MySQL. So we use a MySQL connector. It's provided by the Debezium project, and there's different connectors for SQL Server and Postgres and Mongo. If you're not using one of those, there are other connectors that support other databases, but I'm using MySQL. Here's my database that I'm connecting to. Here's my table that I'd like to get the data from, and a bit of other configuration. So we've got the data is now coming in. I can say show connectors just to make sure it is actually arriving in the system. And it says it is, which means we can go and look at the topics and say show topics. I'm going to use a topic called customers. And if we do this, we can actually go and have a look at that data as it exists in a topic. So you can see the key is based on the user ID. The user ID is 20. Here's their first name, last name, and so on. If I make a change in the database, so let me paste this into the database at the bottom. So here's my database, here's my SQL at the bottom of the screen. At the top of the screen is my Kafka topic with a consumer running against it. Just, you can see the cursor's flashing there. It's waiting for any new messages to arrive. In the database, I run an insert. So watch the top of the screen here. There goes my insert, and there's the new message in that Kafka topic. So we've created a new row in the database, which is now available basically straight away in that Kafka topic. And we can take that Kafka topic in ksqlDB, and we can do this. Instead of creating a stream, streams are Kafka topics, are unbounded series of events with a schema. ksqlDB also has a concept of a table, which has a schema, but is state. It's key value state for a particular, state for a particular key. So we say this, go and create this table. It's keyed based on customer ID against this particular topic. So the topic is still a stream of events. We're just saying to ksqlDB, take that stream of events and reason about it as if it was state. So for every single key, tell me the latest value of that key. Tell me the state of that key. And it's in Avro, so we don't have to type in the rest of the schema. So you say describe customers. And it says, well, there's your nice full schema. And we can also do this. We can say, go and connect to that particular table. And from customers, if it changes, limit 5. So now we're going to the ksqlDB table and saying, show me the state of that table. And you'll notice it matches what's in the database. So we've got a database table, which is state. We capture the changes as a series of events. And that series of events, we treat as state by a semantic construct of a table in ksqlDB. And what that means is, as we change things in, let's run that query again in ksqlDB, but without the limit. So here's the full view of the table. And in my SQLDB, I'm not going to make changes to that data. So you can see here, we've got the new row that we created. So customer ID 42 is Rick Astley. We forgot to give them an email address. Oh no, how on earth are we going to send them emails about our great products? Let's change the database and say, here is their email address. You can see the table updates. The table emits the change in state. If I go to the table in my ksqlDB and say, what is the current state? So let's do it just for customers, where customer ID is 42. It says you can't do that. So we say, well, let's try doing that. And now it's going to say, for customer ID 42, here is the current state. The state was where we had null. The state changed because we received a new event. So we re-emitted the state. But here is the current state of that table. And we can make other changes. We can give them change their club status. And MySQLDB, in MySQL, we're going to make a change to the state, which will get reflected in ksqlDB. We've got too many SQLs going on. So we make a change in MySQL. We update the customers. The state changes in ksqlDB. So we can see the state has been re-emitted there. And if we re-query the table and tell me the current state, it says, well, the current state is this. And all of that is a long-winded way of saying we can take a database which holds state, and we can make that state available within ksqlDB, which means we can then do this. We can join to that table. So we're going to do this. We're going to say, take our stream of ratings, and cancel that. So take our ratings information here and do a join to our customers. So as a rating arrives, we do a join out to our customers. We concatenate things here and change the schema a little bit. And now we get to see, as ratings arrive, who is that particular customer, what's their ID, and what's their club status. So we can echo it to the screen, but we can now also go and create ourselves a new Kafka topic. And this new Kafka topic isn't just saying, well, we'll take the information and we'll filter it for live or test. We'll take that information and we will enrich it, we'll transform it, we'll join it out to all the different things. So we're going to create ourselves a new stream. Here we're saying create a stream and give it a different Kafka topic name, just because you can. And we could change the partitioning, we could change the replicas if we wanted to. We can also say, go and create a stream. And this stream here is going to take that enriched data and it's going to say, now apply that predicate that we were talking about before. If it's not a very good rating, if on a scale of 1 to 5, it's less than 3, so if it's 1 or 2, and the customer who left that rating has got a club status to platinum, go and write it to a new stream, which is backed by a Kafka topic. So we go and do that, and we say show topics. And now we've got some new topics. We've got a topic called ratings enriched, which is the one which is the rating events added with the customer information added into it. And we've got the platinum customers, which is that enriched information filtered for those different conditions. So this is why you might want to daisy chain things. You don't always want to go the whole hog in a single statement. Just like when we build other systems in SQL or in any other code, you don't want to do everything all in one great big go. because probably going to regret that later. You want to say, well, let's do a logical step at a time. Let's enrich it with information about our customers, because that on its own is going to be useful. And we also want to take that and create another derivation just for these unhappy Platinum customers. And with all of this, we can now go and push it into Elasticsearch again, because I like Elasticsearch. I'm going to say take the data, again, use the Elasticsearch sync connector, take data from these two topics, because you can have multiple topics, and go and put it into Elasticsearch. Show connectors, make sure it's working. It says it's working. And now let's head over to Elasticsearch again. And this time, we're going to load up a pre-built dashboard. And this is going to show us the enriched information, as well as, oh, that's a bit big. Let's zoom that a little bit, as well as just the Platinum customers. So down here, we can see we've got the ratings as they come in. So let's set this to refresh so we can see it's near real time. And Kibana's not really designed to be run like this, I don't think. Probably kill my CPU at some point. But we can see that's ticking over. As each rating arrives, it's being enriched and pushed down to Elasticsearch kind of straight away and shown in our near real-time dashboard here. We can see we're breaking it down, doing some nice analytics on it here. And then at the top here, we're calling out that separate data for those Platinum customers. The Platinum customer information is held in a Kafka topic, so you can also subscribe an application to it directly to do push notifications and all that kind of funky stuff. So that's one way you can build these streaming data pipelines, taking data, enriching it, pushing it down to a target system for visualization and analytics. But what about that state that we were talking about earlier, where you can actually say, take this information and do some aggregation against it, and then look it up from an external application. So I want to show you that before we go back to the slides and do some cool questions. So now what we're going to do is, we're going to take this information, let's clear the screen here and give ourselves a bit of space. We're going to create a materialized view of that data. We're going to say, this is going to be a table that holds how many ratings has each customer left within a 15-minute window. So it's here, we can do windowed aggregations. Here it's called a tumbling window, which means you can you get a 15-minute window, and then after that another 15-minute window, and then after that another 15 minutes. You can also have hopping, where it's like a 15-minute window, but it advances every minute. So you get lots of windows. And you can also have session windows. But here we're using a tumbling one. So select the full name and how many ratings. We can also say, also bring in as an aggregate field the different number of ratings, sorry, the star rating that was left each time. So we go and create that table. To start off with, we can just go and have a look at that data. And we're going to use here the same kind of query that we used before, which was a continuous query. And to give it its proper name, it's called a push query, because it pushes the results to us as a client. Here, the client is a command line. We can also use a push query from an external client, whether a Java client or REST API, so we can subscribe to changes. So here we're going to see, select this, the timestamp at which the window started. So they always start at the epoch, so like midnight back in 1970, and it will advance every 15 minutes. So it's not based on when the first event was arrived. It's based on the midnight epoch, with the tumbling window is based on that. The name, the ratings count, and the ratings as that collected set, just for a particular user. So we're going to pull that in, and you can see you've got the window start time. So this one here, so 1645. So this is UTC. So this is the current time window. Let me just pause that, and I'll explain in a moment why it just changed. So if we page up here, you can see, so 1600 UTC, Rika Blaisdell left 117 ratings, and this is actually what they were. And you could do averages and minimums and maximums and other aggregation functions on it like that. But it's telling us per 15 minutes, this is the aggregate value. And that's useful. But what it did down here was it said, well, here's our current time window, and this is current time. And Rika Blaisdell is busy leaving reviews on our website, and every review that comes in is an event. And that event is going to change the state. And if the state changes, ksqlDB is going to tell us about that, because the state has changed, so it emits changes. That's what it says on the end of the SQL statement. So here you can see go from 92 to 94 to 95, and each time we're getting a new rating added onto that collected set. So that's a push query. And like I say, if your application wants to know about when does it change, when does the number of ratings change, you can subscribe to that using a REST API or a Java client, and you'll find that out. But what about if you want to know at this particular point in time, how many ratings had Rika Blaisdell left? I don't want to know about it as a continuous thing. I just want to know as of now. I don't have to subscribe to that stream and kind of like go through it and look for the particular thing. I want to say, for this particular time window, or for this particular user, what's the current value? And we can do that here. So this is what's known as a pull query. And it's called a pull query because you're pulling the value from ksqlDB. So let's give it a sense of a window start time. So the date is the 8th and the date is the 4th. Okay, so now we've said, tell me what the current value is. We've done a pull query against the state. So this is saying for this particular user, at this particular window offset, or window offset is greater than this particular time, what's the current value? And you'll notice down here, it says query terminated, and we're back to like, what should I do next? Run it again, has the value changed? Well, it turns out the value has changed, 105 now. Whereas if I do the same thing, but I say emit changes, it'll say, well, here is the current value. And as that changes, I will tell you about it some more. And down here it says, here's your flashing cursor, press Control-C to interrupt. So push queries, you subscribe to those changes. Pull queries, key value lookup. What is the current value? So let me show you that in context. You can actually take that using a REST API, so using something like Postman, and you can run that ksqlDB statement. So let's fix our window value here. Let's zoom in a bit so you can see what's going on. So we're using the REST API to go against the query endpoint. We're saying select these values from here where the key is this, and the window start time is the 8th and the 4th, and it's greater than this. And if we send that, we get a result back which says, down here, here is the current value. So you've got a time window here, 1615, 1630, 1645, and the different values for those. So it's just, here you go. We could run the same thing as a push query if we wanted to, and then you just get a chunked response and you get any changes as they come in. But you can take that and you can run it from any particular client that you want to. So for example, I was learning Go recently and I've written a Go client for ksqlDB. So in your Go code, you can say like, I'm just going to use ksqlDB to look up these values or to subscribe to changes in these values. So that's the end of the demo. Hopefully it kind of like shone more light onto what I was talking about conceptually, what you can do when it comes to building these streaming data pipelines. I will share on meetup.com, on Twitter, and so all the rest of it, the links to the demo scene repository so you can try it yourself. I'll also share a link to these slides. I'll finish off by sharing a few resources with you, and then we can do some questions. So again, the link to those books, very, very useful stuff. Designing Event-Driven Systems by Ben Stopford, very, very good resource. The Kafka Definitive Guides, got loads and loads of information about the concept and also the practicalities of running Kafka. If you don't want to run Kafka yourself, let us do it for you. So Confluent platform is available as Confluent Cloud. So as a managed service, you get Apache Kafka, you get ksqlDB, you get Kafka Connect, you get Schema Registry, you get various discounts, money off your bill if you sign up using those different codes. So go and give it a try. You can run Confluent platform on premises as well. So again, it's a distribution of Apache Kafka, includes all the different bits I've shown you in the demo today. Hopefully this has been interesting. Hopefully you want to go and learn more about Kafka. To do so, go along to developer.confluent.io. There's tons of tutorials, there's podcasts, there's videos, there's all sorts of material on there to kind of like take you on your developer journey, whether you're brand new to Kafka, whether you're experienced and looking for the next new thing to learn with it. There's tons of resources there. And finally, come along and join the Slack group, the Confluent Community Slack group. It's a huge resource. I think we just hit the 20,000 member mark. So there's a huge number of people in the community. It's a very friendly and welcoming place. So come along and ask questions, help out other folk. There's different channels. So there's a channel for Connect, there's a channel for ksqlDB. So you'll find lots of people on there. I'll finish up by saying there's other talks going into different areas of what I've shown you today. So if you want to learn tons more about Kafka Connect, there's a talk about that. If you're interested in integrating with databases, because that commonly comes up in like questions, then there's a talk all about that. And there's even a talk specifically about databases in terms of Oracle itself and Kafka. So there's tons of resources there. Go and check them out. I'll put them on the slides that I share afterwards. So with that, thank you very much for your time. We've just hit the hour, which is great. So I'll take some questions if there are any.
Yeah, cool. So, Robin, first of all, thank you for the really interesting presentation. Second thing, I read 3 of these books that you showed, and I really recommended all of them. One left, so probably you'll read it. And we have the few questions. Okay, there is 2 options. If you would like, please use the button raise a hand, or we can read. The first one is from Philip, but Philip, you unmute yourself and ask, okay?
Sure. I saw this graphic user interface showing Kibana, Kafka, and some more. Could you tell what's that? Something about this?
Yeah. So let me show you this. Oh, I've closed Kibana, haven't I? So Kibana is there's a screenshot of it here. So Kibana is a part of the Elastic stack you can use for visualizing on top of Elasticsearch. Can you clarify what you mean about the other Kafka tabs?
Yeah, that was the previous window you shown.
I'm not sure which one you mean. So there is Confluent Control Center, which is, there's a developer license and a commercial license, and that gives you a graphical interface for managing your Kafka clusters, for using ksqlDB, for Kafka Connect, and all the rest of it. So that's maybe the other graphical interface you're thinking of.
Okay, thank you.
Great. So another question. So sorry for my pronunciation. Jimmy 4, can you unmute yourself? Okay, we don't hear you.
Okay, I can see the question. What's the future of Zookeeper in the Kafka ecosystem? So the future of it is Kafka is an Apache Foundation project, and it has what are called Kafka improvement proposals, which is what the community put together when they're thinking about changing the API or adding improvements to it. So they're known as KIPs, and there is KIP 500. So if you just Google for like KIP 500, it'll probably come up. It's on a Jira system, and KIP 500 proposes removing Zookeeper from Kafka because we could do without it. So that's the future of Zookeeper in the Kafka ecosystem. Ultimately, it's still, I believe, under discussion. It's not been implemented yet.
Okay, so yeah, another question. Can you use ksql as cluster to share load?
Yes, so ksqlDB can be clustered, and it can share the load amongst the different components. There was a question that I received privately, but I can answer it here, which was, in a ksqlDB cluster, how is the data sync between the different nodes during queries? That is answered. There was a blog post on the Confluent blog about the internals of ksqlDB, which I shan't even pretend to understand how it works. I just use it. The engineers kind of like built this super cool thing, and they've kind of gone into the detail there of how the actual data gets synchronized between the different nodes. There is also on the Confluent Community Slack, so if I go onto that link again, there's a channel called ksqlDB. There's also a ksqlDB dev, where a bunch of the engineers hang out. So for kind of like nitty-gritty questions like that, that's also a great place to go.
Okay, great. The next one, is there any client for KSQL?
Yes, so ksqlDB has now got a Java client as part of its the project itself. That was added in the 0.10 release. There's also an unofficial Golang client, which is one I published recently. So send me a message on Twitter, or have a look on my GitHub, and you can find that there. And there's also a REST API, so that's what the Golang one is written around. The Java one, I don't know about, but there is a Java client as well.
Yes, but I also have another question. This is also related. For example, you showed us Kibana, and as I know, Kibana is a UI interface for managing queries to Elasticsearch. But I mean, is there also some UI tools that will help us to easily query with KSQL? Because, for example,
Yes.
You showed it in terminal, but sometimes it's not so
Yes, absolutely. So there is also a web-based client for KSQL. So again, Confluent Control Center, which if I had a screenshot, I would show you, but it'll take me as long to find it as to describe it. So Confluent Control Center is part of Confluent Platform. There's a developer license available. There's also a commercial license, and it gives you a control center, a management interface, and also a developer interface. So it lets you develop ksqlDB applications. It lets you create connectors. It lets you manage your Kafka clusters. So for example, if you're using Confluent Cloud, then it's as it provided as a service, and the web interface is basically a Confluent Control Center. You can do your ksqlDB through that. If you're using it on premises, on Docker, like I am here, then you can also use Confluent Control Center with that.